Hi everyone. We'll be waiting 2 to 3 minutes before starting the webinar, just to accommodate for the rest of the attendees who are in the middle of connecting. Welcome everyone. Thanks for joining us and thanks for being part of our community. My name is Valen Kolika and I will be your host for today. Just a few reminders before we start. If you have issues viewing the stream at any time during this webinar presentation and are using the web browser version of Teams, please refresh your browser. If you're using the desktop app of Teams, please exit and rejoin. This simply seems to be working if you have any connection issues. Please note that this webinar is being recorded and will be shared publicly. We will post the recordings on our community at aka.ms/security webinars. Now, closed captions in several languages are available during the live broadcast, and you can enable them by clicking on the CC button located at the lower right corner of your screen. Please feel free to ask questions at any time by typing them in the live event Q&A window. Just simply clicking on the Ask Question button. Be aware that any questions you post will be publicly visible. However, if you prefer, you can post your question anonymously by checking the box right below where you enter it. We often get many questions on these webinars, and we will do our best to respond to all of them in real time. In the event, if the answer was not provided, or if you may have additional questions post this event, please don't hesitate to raise them on our Azure Sentinel forum at aka.ms/Azure Sentinel community. If you're listening to this after the fact as a recording, that's also a great place to ask a question. Now, we love to hear your feedback on how we can improve on these webinars, and you can do that at aka.ms/security webinar feedback. And by the way, all the links that I'm announcing have been already shared with you on the chat or the live event Q&A window. If you would like to, I would actually like to invite to join you all on our public community by visiting aka.ms/security community. This is the best way to ensure that you don't miss any future webinars or major announcements. On our community, you can speak directly to our engineering teams that create our security products. You'll actually be able to influence, of course, on our product designs and get early access to changes by doing things like participating in private previews, which, by the way, you can sign up for that at aka.ms/securityprp. You can request features, you can give feedback, review our product roadmaps, register for events, or just simply join in webinars like this. We believe that the best way to improve our products is by removing any barriers between you and the people that create them. So we hope you'll join us. In today's session, Innocent Wafula and Jeremy Tan will guide us through best practices for converting detection rules using Azure Sentinel. Both Innocent and Jeremy are program managers with Azure Sentinel team. And without further ado, I will turn it over to them. Gentlemen, the floor is yours.
Thanks, Valon, and thanks everyone for joining. Today, we shall be covering the topic best practices for converting detection rules from ArcSight, Splunk, and QRadar to Azure Sentinel rules. Co-presenting with me is my colleague Jeremy, and behind the scenes, we also have a bench of deeply technical minds comprised of Naomi Christies, Hisham Saad, Younes Haldi, and Javier Soriano, who will also not only be supporting us with Q&A today, but were also instrumental in helping us to put together the resources we shall be covering in this webinar. But before we begin, a bit of some background. Azure Sentinel is the world's first cloud-native SIEM featuring built-in SOAR and UEBA capabilities. We have seen tremendous uptake since going generally available in September of 2019. Today, Azure Sentinel is already recognized as a leader in the Forrester Wave Security Analytics Platforms report for Q4 2020. As customers continue to migrate from other SIEM solutions into Azure Sentinel, a key task is the translation of existing detection rules into those that map to Azure Sentinel as accurately as possible. Now, there is no straightforward one-to-one mapping from one SIEM to the other, as each SIEM tends to have its own fundamental peculiarities that make such an effort challenging. However, to help facilitate this journey for our customers and our partners, we are putting together a range of resources, starting with this webinar, that are aimed at providing you with as much guidance as possible around how you can migrate your existing rules from ArcSight, QRadar, and Splunk into the analytics rules that are used within Azure Sentinel. So here's what we'll cover today. I'll start us off with an overview of detection rules across SIEMs, then get into a little more detail about Azure Sentinel analytic rules, and then Jeremy will take us through the rule migration workflow, then walk through a sample rule migration for each of the three SIEMs we are focusing on today, and then we'll wrap it up. So rules overview. From a detection perspective, SIEMs fall into two broad categories, event-based and search-based. And this has a fundamental influence on how rules are crafted for each of these types of SIEMs. So event-driven SIEMs rely on correlating events in real time to begin the detection process, and parsing is done at the point of ingestion. Examples of SIEMs that fall into this category would include ArcSight, QRadar, and LogRhythm. Search-based SIEMs, they rely on rules that are based on queries which run at a user-defined frequency on top of a data store. And parsing here typically would happen during the query run process. Examples of SIEMs that fall into this category would be Azure Sentinel, Splunk, and Elastic. So what can we expect from rules? So rules exist to perform two basic functions, detection and enhancing efficiency. For detection, at a bare minimum, rules exist to filter out events perceived to be more important than others, then create alerts on that basis. They can also look at relevant relationships between events and then trigger alerts. Thirdly, they can also look at a number of qualifying events, and once a predetermined threshold is crossed, an alert is triggered. Rules can also be used to detect events occurring in a certain order within a given time frame. So for example, a PowerShell command execution followed by suspicious inbound firewall activity. Lastly, as far as detections goes, rules can compare an established baseline to behavior that deviates from it and then trigger alerts on that basis. When it comes to driving efficiency, rules can filter out events based on allow lists to ignore known outliers, while watchlists, on the other hand, would do the opposite, can promote alerts which contain entities of interest. Under enrichment, rules extend events or alerts with additional information needed for detection or investigation of events by applying threat intelligence, looking up asset information, user information, or geolocation. And lastly, rules can also be used to fix events, for example, linking a file access event with a subsequent suspicious activity. Let us now look at Azure Sentinel analytics rules. There's 4 of them: Microsoft security rules, Fusion, machine learning and behavior analytics, and schedule rules. Microsoft rules generate incidents from down-level Microsoft solutions such as MCAS, Microsoft Cloud App Security, or Microsoft Defender for endpoints. No configuration is needed. You just enable the ones you want and you start detecting. They support comprehensive entity mapping, which allows for a richer investigation experience. I mean, these are first-party alerts, so you understand the schema pretty good and are able to do that. And they're easy to use. They're great if you already have the Microsoft 365 and Azure Defender solution stacks. Fusion, it's actually 1 rule, but with the potential to create up to 70 unique incident types based on detections of advanced multi-stage attacks across the chain of compromise. It correlates multiple low-fidelity signals from various data sources or security solutions to provide high-fidelity, high-severity alerts. It's enabled by default. Machine learning and behavior analytic rules. These templates are based on proprietary Microsoft machine learning algorithms. They're good for detecting anomalous behavior, such as unusual remote desktop or SSH logons. Scheduled alert rules. These are KQL rules based on templates written by our experts who are responsible for defending Microsoft and defending our customers as well. The rules are editable and will form a major part of the migration resources that we have assembled to support your rule conversion efforts. So across the 4 rule types in Azure Sentinel that you see on the screen right now, we have about 200 built-in templates which help to start you off as you embark on your migration journey. All right, let's now look at the alert workflow parts because they determine how Azure Sentinel rules behave. We'll start with the scheduled analytics rule and examine how it moves from an initiating event all the way to an incident. So at the bottom left of your screen there, you'll see 2 parts. So there's a continuous line indicating a path that is always followed, and then the dotted line indicating a path that will be optionally followed. So it all starts with a scheduled rule executing, and it will run over the log analytics database, which contains events, alerts, and incidents. And then on that basis, if the conditions defined are met, an alert will be created. Now, optionally, that alert can trigger a playbook or it can create an incident. Further down, same rule executes again, can create an alert and optionally create an incident. Now, with the alert grouping feature designed to manage alerts and reduce noise, you could also add this alert to an existing incident. Similarly, with the event grouping feature, you are now able to have the scheduled rule create alerts based on events, and each of these alerts could create an incident of themselves, or they could add to an existing incident. In future, we will have the same capabilities that you have today, whereby alerts can trigger playbooks. Incidents will also be able to do so. Scheduled rules have visibility across the entire data store of events, alerts, and incidents, and can go back in time up to a maximum of 14 days, which helps to ensure that queries run in an optimal manner. That was the scheduled analytics rule alert workflow. Let us now look at the alert workflow for the other 3 types of Azure Sentinel rules. So that's Microsoft rules, machine learning and behavior analytics, and Fusion rules. So Microsoft rules, so the alert is already triggered in a down-level first-party solution. So all that the rule does is create an incident. For machine learning and behavioral analytic rules, an incident is directly created, while for Fusion, it will look over Microsoft alerts and other could be third-party solutions such as Palo Alto, and create an incident if the defined conditions are met. Again, like in the case of scheduled rules, incidents generated from these 3 rule types will also be able to trigger playbooks in the future. With that, I will turn it over to Jeremy to take us through the rule migration process.
Thanks, Innocent, for the great overview. Now I'm going to share my screen. All right, can you guys see my screen?
Yes,
Yep.
all good.
Cool. Now, good morning, good afternoon, evening, everyone, depending on where you are. My name is Jeremy. Next, I'll be talking about rule migrations. But first, let's discuss some of the challenges in migrating a rule from other SIEMs to Azure Sentinel. These are some of the commands we hear from the fields, and they are mainly due to lack of reference resources, guidance, or learning resources. Hence, this is one of the reasons we are having this webinar. If some of these commands resonate with you, hopefully you get a better ideas how to perform the migrations after this webinar. Before we dive into the rule migration process from ArcSight, QRadar, and Splunk to Azure Sentinel, let's look at rule components in general. Now, take note that from now on, I'll refer ArcSight, QRadar, and Splunk as third-party SIEM, so that I don't need to mention them individually. Earlier on, Innocent has given a great overview on detection rules. Here we have summarized what are the rule components in general to provide an overview of the different terminology used in each SIEM, because every SIEM is different. As you can see, rule components basically divided into 4. So they are rule types, criteria, trigger conditions, and actions. Now, as for rule types in Azure Sentinel, is what Innocent had mentioned. So we have 4 rule types. We have the schedule, Microsoft Security, machine learning, behavioral analytics, and also fusion. But for some other rules, for example, Splunk, they have schedule, real-time rule types. As for QRadar, they have offense and event rule type. So as I mentioned earlier, every SIEM is different. As for the criteria, take note that in Azure Sentinel, the criteria is mainly defined in the KQL. Now, this will be the most important part of the rule, because this is actually the logics of what you want to detect. Keep in mind that for other SIEMs, there are different options to configure the criteria. For example, in ArcSight, the rule criteria will be defined in rule conditions, whereas in QRadar will be defined in test conditions. Whereas Splunk, which is a query-based rule, they are also defined in their Splunk processing language, same as Sentinel. The trigger conditions, in short, it will be the thresholds in Azure Sentinel. Basically, it means the minimum requirements of the matching events, right, for actions to be taken by the rule. And lastly, we have actions. In Azure Sentinel, we have 2 default actions. They are create alerts and create incidents. We can also leverage Azure Logic Apps, which is our playbooks components, to perform actions, anything besides the 2 default actions that I mentioned. Keep in mind that in other SIEMs, for example, ArcSight, so they have different options in terms of actions. For example, adding result to active list, whereas QRadar, they have options adding result to reference sets. And for those actions, we need to create them in Azure Logic App as part of our playbooks. Right, so let's see how those components be mapped in the respective SIEM. Keep in mind that this is not meant for a competitive comparisons, but rather just to give you guys an overview, the different terminologies in each SIEM. So as I mentioned earlier, for example, the criteria, Azure Sentinel will be defining in KQL, whereas ArcSight and QRadar, they have different user interface. So from personal experience, when a user coming from different SIEM, they will be looking for the similar feature, right, in Azure Sentinel. And hence, hopefully, this summary will help you to identify and give you an overview of the different terminology in different SIEMs. Hence, will make your rule migration easier. All right, so next, let's dive into the migrations process flow. Now, first of all, apologize if this diagram looks busy to you, because rule migration process is not an easy task, right? So it's a complex process. So that's why we have defined a comprehensive workflows to help you in order to migrate your rules efficiently, and also having the high true positive alert rate. Now, just want to give a quick overview on this diagram. So basically, this diagram is divided into three main colors, right? So you see some of the steps are in yellow. So those are the planning and assessment steps, whereas these few steps in gray, so those will be the steps to be performed in the third-party SIEM. I'll call them the information collection steps. So all these steps are important because you need to gather information as accurate as possible before you create the rule in Azure Sentinel. And lastly, those highlighted in blue, those are the tasks to be performed in Azure Sentinel. Now, I do want to mention that because rule migrations is complex, and we, besides having the flow defined, we have also prepared some artifacts or resources in order to help you guys in migrating the rules. Some of the artifacts are basically just compiling existing links that we have, but we also have built new artifacts in order to help you guys to migrate the rules successfully. So those artifacts are highlighted in green, and I will talk about them in a short while with some screenshots. All right, so let me briefly go through all these steps one by one, really briefly, because there are many steps involved, but I want to make sure that you guys fully understand the workflow and also get the whole idea of how this is supposed to be done, in a structured way. Now, first of all, the first step, is the planning step because it's highlighted in yellow. Or orange. Well, I think it's yellow. So basically, this is the preliminary consideration steps. So in order to help you to perform some decision points and also to have a quick overview of the existing rules, we have prepared a checklist. Right, so the checklist will be the items that you might need to review, you might need to perform assessment in your existing environment. So for example, you need to select use cases, and your use cases might be based on, let's say, MITRE ATT&CK framework or maybe business requirements. And you want to identify rules that offer true positive rates, and you need to look at the past historical trending or data in order to identify, right, the correct set of rules. Now, keep in mind that as we mentioned earlier, there's no easy way, there's no shortcuts, right? There's no direct one-to-one conversion. Hence, hopefully, this process will help you to identify, the correct set of rules. So, for example, if you in the past, if you created a rule that monitored Windows Server 2008, right? So let's say today you no longer have Windows Server 2008. So those rules will not be qualified for migration. So these are some of the points that we will, that will be part of the considerations and will be part of the checklist as well. Next step. So once you have gathered a initial list of rules to be migrated, right? Based on, so after you have done your checklist and considerations, the next step is to check what are the out-of-box rules in Azure Sentinel. Now, Azure Sentinel offers an extensive list of out-of-box rule templates where you can enable it, just by a few clicks. So we hope that, by providing you with the built-in templates, that will reduce the needs to migrate some of the rules from your existing theme. So remember we mentioned that there are a couple of machine learning rules, and we have the fusion rules, which the fusion rule itself will be able to cater for 90 incident types. So, all these need to be taken into consideration, because you do not want to migrate a rule to Sentinel and then, it will be duplicates, because we already have something out of the box. And next, we need to refer to the community resources. So for example, subprimes. So subprimes has this threat detection marketplace where you offer rule packages, and you can even deploy those rules from TDM itself to Azure Sentinel. So and currently Shopify is running a promotions where you get certain free rule packages. For example, the Sentinel starter packs or Office 365 rule packages. So make sure you check them out. And as the steps goes by, the numbers of rules needed to be migrated should be reduced, because you'll be leveraging not only out of the box, but also the community resources. Next, another tool by subprimes. So this is a conversion tool called Uncoder.io. I hope you guys are familiar with this, and by the way, we have also offer and subprimes have also done a webinar in the past. So if you want to know more information, you can check out the previous webinar. But these two basically help to convert Sigma rules or queries from one SIEMs to another SIEMs, including Azure Sentinel. And be sure to check it out and make sure to find out whether any of the use cases are able to be converted into Azure Sentinel query. Now, on the query, basically Azure Sentinel is built on top of Azure Log Analytics, and Azure Log Analytics is powered by Kusto. We refer the query language as KQL or Kusto query language, because KQL is fundamental, and I'm sure that in the the rule component diagrams I mentioned that the logics in Azure Sentinel will be defined in KQL. Hence, having basic knowledge of KQL is fundamental. But it doesn't matter whether you are a beginner or you are an experienced user in KQL. We have compiled a list of resources based on expertise level. So if you are a beginner, we have a couple of learning resources for beginners, so that it's not too overwhelming or daunting. If you are a experienced user, we do have some advanced topics that will suit your needs. All right, so those are the planning tasks. That means by now, arriving at this stage means that you already have defined a set of rules that you need to migrate. You have checked and confirmed that those use cases are not part of the out of the box, are not part of the community resources, and those rules are providing high value, true positive in the past, right? The next step will be performing information collections, right, in your third-party SIEM. So the reason why we are performing all these steps is to gather information so that we can use them in creating the rule in Azure Sentinel. Now, first, let's evaluate the first steps for the information collection. As I mentioned earlier, Azure Sentinel is built on top of Log Analytics. and log analytics has this table concept that means different data sources or different data types, are stored in different tables. Now, give you an example. If you are collecting Windows security logs from the log analytics agent, it will be stored in a table called security events table. All right, so we have compiled a table mapping, a data sources to table mapping for your convenience, so that you can reference, for example, if you are from ArcSight and you are collecting, the Azure AD logs, so this will be the table associated with that. And we will also have a column for the data collection methods, because the destination table basically depends on the collection methods as well. So, for example, if you have a custom collections via Logic app or Azure function, so that would be stored in a custom table. So we want to make sure that you guys are aware what are especially those known tables or native tables that we have, and how does that map, right, your third-party SIEM. So once you have identified the data sources or the table name, the next step is to identify what are the attributes, what are the fields, and what are the entities, right, that you use in the rules, in your existing rules in the third-party SIEM. So attributes would be the alert names or description that you use, and maybe the severity, what are the MITRE tactics. So all this information will be specified when you create rule in Azure Sentinel. And also for fields. So for example, if you are tracking Windows event ID, right? So you'll be using the event ID for performing filtering. So those will be the fields that you need to use in constructing your KQL. And also for entities, because Azure Sentinel has a feature called investigation graph that allows the SOC analyst to look at the correlation. So, for example, what are the different types of alerts which are related to a specific entity, right? So you'll be able to see that in a single graph. But in order to utilize that, you need to perform entity mapping in the root page, in the root setting page in Azure Sentinel. Hence, knowing what are the entities involved in your rules will be helpful. So, for example, if you are monitoring specific events, like, for example, failure logon events, so your entity will probably be the host name or the account name, right? So those are the main entities that you want to use for mapping. Right. So the next step is probably the most important and complicated step, which is the root criteria or logics. The reason why it's complicated is because remember what I mentioned in the past, that if you come from another SIEM, there are different ways of specifying the logics. Whereas in Azure Sentinel, you use KQL, so it's a different type of methods, right? So in order to help you to get a better idea, or help you to construct your query, we have prepared a couple of rule samples according to your SIEM. For example, ArcSight and QRadar, because they are the event-based SIEM, right? So they have user interface configuring the criteria for example, the rule conditions and the test conditions. So we have prepared a mapping of sample. So I'll just give you a quick overview, because this has not been published yet. We plan to publish this soon after the webinar. So this is how it looks like. So for example, let me just scroll up. Let's say for ArcSight, so these are the rule types. So for example, filter, right? So this is how it looks like, and this is how the KQL would look like. Now, bear in mind that this is not a use case, right? A specific use case example, right? So we are not talking about a specific use case like, hey, this is brute force attack, this is monitoring, login, or etc. So this is basically a sample for a rule type. So you can see this rule type is performing a filtering with the AND operator, right? And this is how it looks like. So if you have a rule type with all operators, this will be the options. And if you are using, let's say, one of the common ones would be using active list. So if you are using active list in ArcSight, so what would be the options? So for example, the the equivalence feature, right, of active list in Azure Sentinel is watch list, and here you get the reference, the links to it, some sample KQL that help you to construct. So this will not I wouldn't say that this is 100% going to address all your use cases because we can't cover everything. But we this is just a starting point, and this document will be uploaded into our GitHub repository, Azure Sentinel GitHub. Hopefully, if some of you who are experienced in converting rules from other SIEMs into Azure Sentinel will be able to help and contribute to these artifacts. Right. So, for example, if our partners or if you are users that experience in converting ArcSight, right? So, please help to contribute. You can take some screenshot and also the KQL that you have, sample KQL that you have developed in the past, so that other community members will be able to benefit, right, from this. And also same goes with QRadar. Again, QRadar, we have some screenshots of test conditions and what are the sample KQL associated to those test conditions. And again, we can't cover everything. So hopefully, if you are experienced in converting those, rules from QRadar to Azure Sentinel, please help to contribute once this is made available in Azure Sentinel GitHub. And so earlier on, I was talking about these artifacts. Next would be Splunk, because Splunk is a query-based SIEM. It's similar to Azure Sentinel using query. Hence, most of the time, user will be dealing with query as well. Hence, we have prepared a SPL to KQL mapping document. So this is how it looks like. And again, we have yet to publish this. This will be published soon after the webinar. And all this example, the SPL example actually taken from the Splunk, quick reference. And we have specified the equivalence KQL commands and also example and references, so that hopefully this will help you in converting your Splunk processing language to crystal query language. Now, you might see some of this SPL to KQL conversion document maybe in some blogs or in some other places, but we hope that we will use this to build a extensive list of repository, so that in the future you can go to one single place to refer to the sample commands. And also just want to emphasize, we need the power and the help of the community to contribute to make this list as comprehensive as possible. All right, so by referring to these documents, and you should be able to get some ideas how your query is gonna be, right? So next we'll be specifying the trigger condition. So I mentioned earlier, the trigger condition basically is your threshold, right? It's your requirement for the rule to trigger an action. It could be the action could be just firing an incident, right? Just as simple as that. And of course, sometimes or most of the time, you associate with the amount of time frame. So, for example, I want to, if let's say X amount of events within a specific time frame, I want to generate an alert. And moving on will be the actions. So action will be, what you want to perform, right? When your rule criteria matches your trigger conditions. A simple one, as I mentioned, will be creating incidents, but you could specify something more than that. For example, when the incident trigger, right, it is related to the IP address, right? I want to look up into a third-party tool and check the IP reputations, or maybe I would like to cross-check with VirusTotal, right? So all these need to be built in Logic App, but we do have extensive list of samples in our Azure Sentinel GitHub, so be sure to check it out. So basically, in our Azure Sentinel GitHub, you'll find a lot of useful resources. So not only the actions, but also detection rules, hunting queries, and many more. All right, so these are the steps to be performed, right, in your third-party SIEMs. So by now, you should have a list of rules that you need to migrate. You should have your data sources. You should know the tables, right, that you need to query in Azure Sentinel. You should know what are the fields that you need to correlate, that you need to perform filtering. You should have the ideas of constructing the KQL based on the samples or the documents. You should know what's the thresholds, right? And you should also know if there's any additional steps that you need to perform apart from creating alerts or incident, right? So with all this information gathering, you are good to go to the next step, which is all the tasks that need to perform in Azure Sentinel, right? So I also want to mention that if you have gotten your query, let's say from the conversion tool, like Uncoder, it's good to go through the review, right? So basically, you still need to identify the condition, right? You still need to identify the actions, but basically the conversion will help you to skip a couple of steps because you already have a query, you already know what are the fields and what are the data sources, but do not create the rule directly once you have the query because you need to go through the steps and perform the testing. Right. Speaking about testing and reviewing the KQL. So basically, the first steps to be performed in Azure Sentinel will be constructing the query. Based on the samples, based on the learning resources, and then based on maybe communities, examples. So this is where you will build, you will test. So you could test it in the log page, right, with your existing data. Now keep in mind that it also depends on data sources, but because we want to focus on the rule migration process. So we never really talk about data sources because it all depends on data sources. For example, if you want to monitor Windows events, obviously you need to bring in Windows events, but that will be a separate conversation. But just to keep in mind that it's all based on data sources, and the mapping table will help you to identify the table name and the data collections method. Now, so once you are satisfied with the query that you have built and you have tested it with your existing data, the next the challenging part is to ensure that your query is built based on best practices and your query is optimized. So that when running in Sentinel, you won't encounter any performance issue. Like for example, your query is running for a long time, right? You don't want that to happen. Now, we do have some guidance on the KQL optimization. So we do have it today. It's not a new document, but we have helped to compile all these resources in a single place. And again, this will make available. And basically, oh, by the way, just forgot to mention that after this webinar, with all these resources, besides the resources, there will also be a blog, company blogs will be published to explain the similar process. So yeah, for the make sure to watch that space. And so after that, once you have the query, now this will be the easiest task. Basically, you just need to specify all the information that you have gathered. For example, the name, the descriptions, mother tag, the logics, right? So you'll be specifying here, and you creating the rule. Now the next step will be an important step, but sometimes might be ignored by some users, which is the testing, right? So make sure that you test your rules once you created it, right? Do not leave it, like just turn it on, leave it there, right? And just wait for something to happen, right? So that's not right. So make sure you test it, and by right you should already identify your test script or your use cases. So that is part of the checklist or the considerations. So for example, if you are monitoring the Windows fail to log on events, right? So your test scenario might be, hey, maybe specify the wrong password, right? And then see whether would it generate any alerts or incident. Now, if you are getting the expected result, that's great. If not, that means they might be something wrong, right? It might be because your query, right? Something wrong with your query. It could because you have specified the wrong thresholds. Your thresholds either too high or too low. So need to go back to step number 6 to revisit. So the first thing, obviously, to revisit your KQL, right? You need to review and test again. After that, if let's say your query is fine, probably it's a threshold. You might need to update your rules. Update the thresholds or update the intervals. So this loop or this process is we'll call it the tuning process, right? So this is equivalent. This is also important. And make sure that you get the expected result, right? And to call the rule fit for the production environment. And finally, we have put this step as optional. So basically, this will depends on what you have identified in this step. Number 5, right? So if you have any actions apart from creating incidents, apart from creating alerts, so basically you need to create a playbooks by leveraging Azure Logic Apps. Now this is a sample screenshot if you haven't used it before. As I mentioned, we also have some sample templates in our Azure Sentinel GitHub, so make sure you check it out. The reason why we name this, we label this optional is because if you were just to create alerts or incidents, that means you do not need to create additional actions. But if you need to create additional action, so for example, you want to add your results right into the watch list, right, or the active list that you call in ArcSight. So you have to create a logic app to do that. All right. Now, so hopefully that will give you an idea of the entire process. Now, to put this into actions, so we have defined 3 use cases. So one use case per scene. So let's look at that. Right? Let's do like a walkthrough, right? Based on the workflows that we have defined. So use case number 1. So this is a rule from ArcSight. So this rule basically, we'll look for the account removal activities, right, with all this the event ID. And take note that there's an active list, right? So you check whether a user that removed, whether it is part of the active list. So by the way, this is active list, just a typo here. So basically, so this is the rule conditions, right? You monitor the event ID for account removal, and after that, we'll cross-check whether the user is part of the active list. And then if it is, we'll raise a incident. Now, to do a walkthrough, let's compare them side by side. So on the left-hand side will be the flows that I just mentioned, and this is the use case. On the right-hand side will be the potential outcome, right, from each step. So let's say the first step, you review the checklist, your considerations, and the output. Obviously, we've done the review. You've got your list of rules, right? And next, you will check our built-in templates for out-of-the-box rules, and you confirm that it's not available. And followed by checking in the community resources such as the SOC Prime PDM, and you confirm that it's not there. And having a try on the conversion tool, and then you confirm that it's not converted. And of course, the KQL is important, and make sure that you have the basics, at least the basics in KQL. So once you have done all this, that means you are good to perform your migration, starting by identifying your data sources. So for example, this is a Windows security events, right? So based on the mapping table, this will be in Azure Sentinel, this will be security event table. Followed by identifying the attributes, the fields, entities. So based on the rules, obviously event ID, right? The target account, the member name. So those are the fields required for filtering. So as for entity, remember I mentioned that this is going to be important in Azure Sentinel as part of the entity mapping for investigations. So for example, for this use case, let's say the target account and computer will be mapped, and after that, define a rule logic. So by referring to the sample document that I just showed you earlier, so this is a use case with active list. So you can refer to the sample. By looking at a sample, you know that okay, so watch this is required in this use case. And that's followed by identifying the trigger conditions, which is the thresholds, and also the intervals, how frequent you want to perform the checks. Identify your actions. To keep this simple, just treat it as the action is just to create an incident, right? Nothing fancy. And then we'll proceed with constructing the KQL by following the sample and also the learning resources and some of the reference in the Azure Sentinel GitHub. So next we'll be creating the rules, and after that, performing the testing. So hopefully this makes sense. Now I'll proceed with the second use case. So this is QRadar. So the test condition is to check for missing the Palo Alto logs, right? In the last 1 hour. So again, I'll go through the same workflow, right? But this is different use case. So I'll skip the first few steps because these are the assessment steps. So the outcome probably the same. So I'll quickly skip them, and let's go to identifying the data sources, right? So because Palo Alto, so if using Ceph in Azure Sentinel, that will be stored in the common security logs table, and then identifying the fields, entities. So those will be the fields that need to be identified. Let's treat it as I have a step collection server in Azure as part of the VM, and hence my entity will be the resource ID of that step collector. And then, referring to the sample, again, so this is not a complex use case, basically just filtering. And after that, identifying the thresholds. And again, the rule actions will just keep it simple, creating. So in QRadar, let's imagine that this the action is to create offense, so hence will be create incidents, and we'll construct the query. So this is just a sample how it's gonna looks like. And again, the same step you create is by the rule by specifying all the information that you gather in the previous steps, and perform the testing, and also I'll skip the last step because the action is just create incidents, hence there's nothing extra that we need to create. And the final use case, so Splunk. So this is a sample query. Again, this sample query is looking for brute force attack. So again, we'll go through the same workflows. So just to give you an idea, right? So how it gonna works across all the SIEMs, and again, we're gonna skip the assessment steps. And then the first of all, the data source will be the Windows event, right? The security event. So hence security event table. The entity would be the fields, and the entity will be event ID, account, right? Time generated, computer. So entity will probably be account and computer. So the criteria. So this will be based on the SPL to KQL mapping. So hopefully we'll be able to find some of the operators, equivalence operators in KQL. So identifying the trigger, which is a threshold. I'll quickly skip that. So this is the same, and let's say this is just creating incidents in Sentinel, and then we'll be constructing the rule. So based on the sample, based on the commands mapping, and some of the sample references in the community resources, and creating the rules the same, and also perform the testing on the rule. So yeah, so hopefully the three use cases will give you a better idea, right? So about the entire workflows. Now we are almost up to time. So let me just wrap it up. So the takeaway. So basically, as you have seen, right? So the rule migration is not a trivial task, right? It's not an easy task. So we need to ensure that we have a clear, strategy and planning in place. And again, this is a involving undertaking, and it's continuation. It's a continuous process. Make sure that you've done your proper planning, and you have your identify the resources, and the training, the education that need to be done. For example, like KQL. So all these are important, right, to ensure a proper and a successful rule migrations. So if you still remember the challenges, right, those commands and those voices that are in the previous slide. So hopefully by reviewing all these workflows, that this will make sense, and that will give you a better idea. And lastly, again, I just want to encourage once those artifacts are being published, please help to contribute, to the artifact, especially the sample, the rule samples, which I think if we have a extensive, list, right, so many people will benefit from it. All right, so that's all from my end. So I'll hand it over to Valon.
Well, thank you so much, guys. This was excellent content, and we did receive lots of questions, and the team has been answering here. And now we're almost at time to end this webinar, but there were some questions around roadmap and plan migration and so on. So I'm suggesting the folks to go and sign up for our private preview community. And I believe we have shared those links earlier. This is the aka.ms/securityprp. I'm sure we'll have an answer on those kind of questions. And I think there were some questions regarding data sources, table mapping that was showed earlier, and then some other resources that you guys shared. I know we've been pushing and saying that they'll be available in GitHub community as well as blog. Do you have a time frame for that?
There's no specific time frame, but yeah, we'll try to publish that as soon as possible. We don't want to specify as a specific time frame because things might change, and and basically to publish that into GitHub repository, there's a reviewing process. So we'll publish it as soon as possible after the webinar.
Okay, great.
Yeah,
thank you so
I think
much.
maybe what we can say is that they are ready, so that's a good thing. It's simply at the review process that might take a while, but all the resources are ready. As you could see, we are using the ones we actually are going to share with you.
Perfect. Thank you so much. Okay, so next week we'll be hosting 2 webinars, different topics, products, but complementing one another. And on Monday, that is on February 22nd, Leaf will cover on what tracking an attacker email infrastructure tells us about persistent cyber criminal operations using Microsoft 365 Defender. And then next day on Tuesday, February 23rd, Yuri and Safina will go over on why security hygiene should be your #1 priority. You will learn in this webinar on how to leverage the Azure Security Center Secure Score and help enhance your security posture and the best practice for continuous improvement of your secure score. And to register for this, if you haven't done so yet, and look up at other upcoming webinars, please visit us at aka.ms/security-webinars. In case we missed to answer your question, or if you have additional questions, please visit the Azure Sentinel forum at aka.ms/Azure Sentinel community. And I would like to close this webinar by thanking Innocent and Jeremy for an excellent presentation. Thank you to the rest of the team who helped answering questions. And most of all, I want to thank all of you for being a part of our community and for joining us on these webinars. We hope to see you next time. Goodbye.